Okay, so this is for Chapter 3, Objective 3 on increasing and decreasing functions. And so the two things that we have to work on for this lesson is how do we test for where our function is increasing and decreasing, and how do we use that information in what's called the first derivative test to find relative maximum and minimum. So if you can go ahead and press pause right now and let the students copy down what's on the screen. So test for increasing and decreasing, this needs to be copied down into your notes, including the first derivative test. So go ahead and press pause. Okay, so now that you have this copied down, it's important that you put for your summary or your note cards that you do a portion to where you know that this is how you tell for increasing and decreasing, so that should go in your summary. And then also the first derivative test, we're going to do a shortcut way to write this, but that should go in your note cards as well. So let's go ahead and look to see what this says. So if we have a function that is continuous on the closed interval and differentiable on the open interval. So this is going to be pretty much a standard for all of our definitions, theorems, and tests, that we want a continuous and differentiable function. So this is saying that if your slopes are greater than 0, so if your derivative is greater than 0 for all x values on the open interval, then we say that f is increasing on the closed interval. Most of the time, though, when we're answering our questions, they will ask you find the open intervals to where your function is increasing. So if your slopes are positive, your function is increasing. And then here, if your slopes are negative, then your function is decreasing. And then if your slope is 0, your function is constant. And if it's always increasing, it's strictly monotonic. Or if it's always decreasing, strictly monotonic. So we're just going to do a little picture here so we can kind of make sure we understand that piece. So I'm just going to do a parabola graph. So if I take a look at this graph, I know just from my past math classes that as I'm going downhill, I'm saying that graph is decreasing. As I'm going uphill, my graph is increasing. So as I move from left to right, I'm decreasing, then increasing. So the calculus definition piece is just taking on the form that at any particular section along here, if I were to draw a tangent line, the slope of that tangent line is negative. And that is what this is saying. So if my slope of my tangent line is negative, right, then my function is decreasing. So it's just adding a calculus component. And then if I look over here on this side and I were to pick any point on this line on this section and I were to draw my tangent line, I see that my tangent line has a slope that is positive. So therefore my function would be increasing on that section. And then any place where my slope is 0, I would say, okay, I'm constant. Okay, so what does the first derivative test say? So the first derivative test says that we have our critical numbers. So we're talking about our critical numbers, which remember we find when the derivative is 0 or undefined. So if we have our critical numbers on a continuous function on some open interval containing c, and the function is differentiable on the interval, but maybe not at c, right? Because the critical numbers can come from non-differentiable pieces, sharp turns. Then f of c can either be a relative minimum or a relative maximum. So we have a relative minimum if f prime changes from negative to positive at c. And we have, so this is our shortcut in our summary, what we may want to write instead is, so we have a relative min when f prime changes from negative to positive. So when f prime goes from negative to positive. So if the derivative goes from a negative to a positive, then I have a relative minimum. And then it's going to have to, in order for it to transfer from negative to positive, it's either hitting 0, which is my critical number, or undefined, which would be at a sharp turn. And then my relative max, so my relative maximum is when I go, my derivative goes from positive to negative. And the only way it can go from a positive to negative is if it hits a 0 or undefined, which is at my critical number. Okay? And so something along that line should go into your note cards. You don't need to write the whole summary, but you're welcome to. You could also just do a shortcut. Okay, so we have to be able to do this graphically, like looking at a picture, and then also algebraically. So let's take a look at a graph. So the directions ask us to identify the open intervals on which the function is increasing and decreasing. So I just have a basic cubic here, and then I'm going to go ahead and scale it. So I'm just going to have my max here be at -1, and then my intercept at -2. And then at 1 and 2. So all I'm going to do is decide, okay, where is my function increasing? So f is increasing. So it's increasing wherever I'm going, basically uphill, right? And that should also be where my slopes are positive. So if I look right here, I'm moving uphill, and I know that the slope of any tangent line in this section would be positive. So from -infinity until I get to here, which is -1, and it asks for open intervals, so open. And then I start to decrease, so now I'm going downhill. And then union, so notation, right? So the first section, and then union, the second section. So the second part, I'm going uphill, is when I start here at my critical number here at 1, and then go to infinity. So from 1 to infinity. So if I were to look at this section here and this section here, those are both going uphill, and they all have derivatives that would be positive, because if I were to draw a tangent line that has a positive slope. And so then f is decreasing on this section in between, so between -1 and 1. So if I were to look at this section right here, right, any tangent line I were to look on that, I would have a negative slope. And so by the calculus definition, then I have a decreasing function, right? Or that's how I could test for a decreasing function. So that's just observation. Okay. So then the other thing we have to do is we have to do it algebraically. So I want to find the critical number, so that's the first part, if there are any. And then I also want to find the open intervals on which f is increasing and decreasing. And then I also want to locate all relative extrema. So I'm going to be using the first derivative test on here as well. Okay, so for our steps, is we want to find our critical numbers. So in order to find our critical numbers, we want to take the derivative equal to 0. Okay, So we're going to find f prime of x, and then we're going to equal it to 0 and also look for places where it may be undefined. And that's to find our critical numbers, right? So to find our critical numbers, we take our derivative, equal it to 0, and look for places where it's undefined. Okay, so you guys find the derivative before I find it for you. So that would be 6x squared plus 6x minus 12. So now I have to take the derivative, equal it to 0. So I'm going to factor out a 6 here at the same time. And then factor again. And then set each factor equal to 0. So just by solving, so this is all our algebra here. So we have one step of calculus, so take the derivative, and then from there we set it equal to 0, so just by factoring. So then here's my critical numbers, which is the first part of the question, right? So these are our critical numbers. And there's no place where this could be undefined because I don't have any fractions or anything to worry about. So that's the first step, find the critical numbers. And so now they're asking for what are your open intervals on which f is increasing or decreasing. So then what I want to do is I want to do what is called a f prime number line. So I am going to set up a x-axis number line. And I'm going to label any critical numbers, if there were any undefined problems, like if I have any domain issues, I would evaluate or set those numbers on as well. So set up a number line, and then on that number line, I'm going to label my critical numbers. And then if there happens to be any vertical asymptotes or domain issues, I would label those as well. So for example, if this was like divided by x minus 1, I would also make sure that x equals 1 would be on that number line as well. Okay, so I'm setting up a number line, and this is going to be part of my test. And so I'm going to do an f prime number line, and I'm going to label it so that I'm knowing I'm evaluating into the derivative. So I'm calling this f prime so that I know to evaluate anything that shows up into here onto my derivative. So I only have my critical numbers, so at -2 and 1. And so I'm just going to put, -2 and 1 on here, knowing that this really represents every number though. So this would be 1, 2, 3, 1, 0, -1, -2, -2. So all of the numbers are on here, but I know that these are critical numbers, so I'm going to mark them as critical numbers. And then what I'm going to do is I'm going to basically apply the first derivative test right now. And how I apply that is I look to see, what is happening to the lefts and the right. So I want to know what kinds of slopes are less than -2. Am I getting positive slopes or negative slopes? And then what kind of slope am I getting between -2 and 1? And what kind of slope am I getting greater than 1? So now I want to test each section. And I'm doing that to determine the sign of the slope. Because when I take a derivative, and then evaluate that derivative, I'm finding a slope value. And I want to know, well, what kind of slope? Am I getting a positive slope, a negative slope? What kind of slope would I do? So I'm just going to choose a number in each section, and I can pick any number that I want. I try to pick convenient numbers. So if I were to choose a number smaller than -2, I wouldn't pick -12.5. I wouldn't pick -pi, -e. I would pick, okay, what's smaller than -2, that's going to work. So I'm going to choose x equaling -3. So I'm going to pick -3 and evaluate it into f prime. And then I'm going to choose a number between -2 and 1. And again, I can pick any number that I want. So I'm going to pick 0. So I'm going to choose 0. And then I'm going to pick any number greater than 1. So say 2. So I'm just choosing numbers in that interval. And I know that regardless of what I pick, as long as it's less than -2, I should get the same signed slope, because my slopes are only going to change at my critical numbers if they change at all. So I can choose -3, my neighbor may pick -4, but we should both get some sort of positive or negative value. And I don't care if it's +5 or +6, I just care that it's positive. So most of the time I would do this as mental math, but for the sake of notes I'm going to write it out. So I'm going to go to my derivative here, and I'm going to pick and substitute -3 in for x. So all of these are my derivatives. So when I substitute in, and if I had to do this by hand and put -3, I'm not going to put it into here because that's a lot more arithmetic than I want to do. And likewise down here. I'm going to choose it down here because doing -3 plus 2 and -3 minus 1 is more manageable than trying to re-evaluate -3 into here. So I'm going to evaluate at -3. And again, most of the time this would be mental math, and as soon as we get what's happening, it can turn into that. So here's my derivative that I'm choosing to use, and I'm going to replace x with -3. And then again, I don't care if it's you know, a particular number. I care, is it positive, is it negative? So here I know -3 plus 2 is a negative number. So I'm just going to put a negative above here. So I don't care what this is, I just know it's negative. And then -3 minus 1, again, I don't care that it's -4, I just care that it's negative. And so when I multiply this positive number with two negatives, I'm going to get a positive value. So if I worked this out, I would actually get that it's positive 24. But again, I don't care that it's 24, I care that it's positive. So that means that every slope under -2 is positive. So every slope under -2 will be positive. So now I'm going to do the same thing for 0. So I'm going to go into the same equation and replace x with 0. Okay. Now again, I'm just going to go positive versus negative. So 0 plus 2 will be a positive number. 0 minus 1 is a negative number. So I have a positive times a negative, so that means I would get a negative number. So that means every slope between -2 and 1 is negative. And then one more, we're going to evaluate at 2. So same equation, but replace x with 2. Two plus 2, positive number. 2 minus 1, positive number. So when I multiply all my positives together, oops, I don't know where that 0 came from, I would get a positive. And so that means every slope greater than 1 is positive. Okay? All right, so I ended up taking up more room, so I'm going to carry on over to this side here to finish this out. So now to finish answering the question, where is my function increasing or decreasing? So it's increasing, right? According to the definition, whenever my slopes are positive. So my slopes are positive here and here, so f prime is positive, so my function must be increasing. So f is increasing from negative infinity to negative 2, and then again from 1 to infinity. So wherever my slopes are positive, so think of positive slopes look like that, right? So positive slopes look like that. That means my function itself must be increasing. And then wherever my slopes are negative, so like this, that means my function must be decreasing. So if my slopes are negative, my function is decreasing. Okay? And then finally for my relative extrema, I need to look for maxes and mins. So I have a max, so I'm going to go back to the definition here real quick. If my derivative switches from positive to negative, because if my derivative goes from positive to negative, right, it's going uphill then downhill, I'm going to create a max. If I go from downhill to uphill, I'm going to create a min. Okay. So if f prime is if f prime is positive, that means f is increasing, right? So f is increasing, and then f switches to decreasing, what must happen here? So if f increases then decreases, right? F prime goes from positive to negative, I must have a max. So I have a relative max at negative 2, and then I'll have to find the y value. And then my minimum, so f is decreasing, then f is increasing, right? So f increases, so we go from decreasing to increasing, so that must mean I have a minimum at 1. So now I have to evaluate at negative 2 and 1. So I know x is negative 2, I know x is 1. So I just need to substitute that in to find the value. And then I go the cheater way and just call it negative 2 and f of 1. So you're welcome to plug negative 2 into the equation and come up with its y value, or you can just write it in notation like that. Okay, let's do one more here, and then we'll call it good. Okay, so first find our critical number. So we're going to take that derivative. We'll have to do product rule here. Okay, so 1 d2 plus 2 and then d1. Okay, and then I'm going to simplify this just a little bit so it's a little cleaner. So the 2 and the x minus 5 are part of my numerator, and the 3 and x to the 1/3 is part of my denominator. So then equal it to 0. So now we finally have a fraction here, so that means I also have to look for undefined. So this function is going to be undefined when x is 0 because I can't divide by 0. So I already know right away, so I'm going to do that over here just to remind me that I have a critical number at x equals 0 because that's where it's undefined, right? Because if I divide by 0, I'm undefined. And it's part of my domain because I could let x be 0 up here, so then that is a critical number, not something out of my domain. Okay, so now I'm going to go ahead and solve for 0. So I'm going to subtract this over to the other side. And then multiply over. So add my powers, so 2/3 and 1/3 is 1, so I would just get 3x. And then distribute. So 3x to the 1/3 times x to the 2/3 is just 3x to the first power. And then you guys can solve for x yourself on that. So you should have got x equals 2. So I have two critical numbers. X equals 2 is when it's 0, and x equals 0 is when it was undefined. Whoops. So then now I'm going to set up my number line. Label my critical numbers. So for this one here, I have to do a little bit more work in substituting in, because my derivative isn't as easy, right? So here's my derivative. So I'm going to choose values to use. So I'm going to use -1, and then between 0 and 2 is 1. And then if I had to do this in my head, like, and not use a calculator, I would choose a number I can take the cube root of, because it's a cube root function, so cube roots. So I know the cube root of 8, so I could do 8 in here, but I can also just use my calculator and type those numbers in. So, which is what I would do. So f prime of -1. So I would substitute -1 into here, but I would actually use my calculator. So, which I did already. So if I replace x with -1 into this whole equation, so I typed it into my calculator, I get a positive value. And again, I don't care what, if it's, you know, +2 or whatever, I just care that it's positive. And then when I evaluated at 1, I ended up getting a negative. And evaluating at 8, I ended up with a positive. So because my slopes are positive, then my function itself is increasing. Because my slopes are negative, my function itself is decreasing. Because my function is positive, because my slopes are positive, my function is increasing. Now at 0, I would have a sharp turn here, right? Because this is where it's not differentiable. And then a smooth curve here. So then to write out my, so now I have to analyze it. So then for my analysis, I would say that f is increasing wherever my slopes were positive, so from -infinity to 0, and then again from 2 to infinity. And then f is decreasing wherever my slopes were negative, and that was between 0 and 2. And then I have a relative maximum where my function goes from increasing to decreasing, so that would be at 0. And then a relative minimum where I'm going from decreasing to increasing, so that would be at 2. All right, and there you go.